So this is definite integration, and so before we were doing indefinite integration. Today is the 11th. Okay. Okay, so this is kind of the important why we integrate. So when we integrate a region under a curve, we are finding a formula for the area under the curve. So for example, let's see if we remember how to integrate. I'll give you a nice easy one. X cubed plus 2x. What do I get when I integrate that?
Add 1 to the power
Yep.
and multiply it by the new power?
Nope. Yeah, 5 by the new power.
Oh, so it's x to the power of 4 over 4.
Yep.
Plus
Anybody can help me?
squared.
X squared, right, good. Yeah, you're sorry, Jesse, to cut you off, but yeah, you're right. So you add 1, it's going to be 2x squared over 2. The 2's cancel. And then what also do you must put when you're integrating? If it's this is indefinite, I'll explain why in a second. Yep, good, Jaden. You have to have your plus c. So what we're actually doing here is, if I bring up Desmos, graphing calculator, and we are graphing, what did we say? Y equals x cubed plus 2x squared. Was that the curve? All right, so we've got just plus 2x. Okay, where is it? Oh. Okay, so we have this curve, okay, x cubed plus 2x. And is that trying to get in? Sorry, one sec. Hey, Marco. Hey, Marco. No, that's cool. I sent it out a bit late. I'm recording this as well, so you can also see it on the recording, but feel free to follow along. We're just doing about definite integration. We're integrating x cubed plus 2x. And that produces x to the 4 over 4 plus x squared. Yep, plus c. And what that means is this formula, x to the 4 over 4 plus x squared, represents the formula for the area underneath this curve. All right? Okay, so it's a formula for the area underneath this curve. Yes, Jesse?
Underneath like the entire line?
Underneath the entire thing, yeah.
So everything on that side?
Pretty much, yes. Okay. Yes, yeah, everything on this side. So it's everything underneath this curve, that's the area. And, well, I should really say, it's the formula underneath the curve and the x-axis. So it's everything underneath here down to the x-axis, everything from this part to the x-axis. Let me just draw on this to make that more clear. How do I do this? keep clicking on the same thing. That's not helpful. I don't know what I can do. Let's go with this, nothing. Let's copy. And paste it. Okay. Right. This x cubed plus 2x is this curve. This represents the area underneath the curve and the x-axis. So it's all of this stuff. Yep, and that's going to continue. But it's also all of this stuff. Okay, it's always the curve and the x-axis. Okay. So when I talk about definite integrals, that means that we're going to be integrating between 2 points. Okay, so let's say we're going to. So when we find, let's say the integral between 1 and 2, and let's do the same curve. This means find the area between the curve and x-axis between x equals 1 and x equals 2. So for example, so this time there is 1, there is 2. I'm integrating between this point and also this one. Which means I'm finding the area underneath the curve on the x-axis. So I'm finding that particular area there, okay, as an actual value. Sorry, this picture's not great, but does that make sense? You know, can you see what I mean? Yeah? Like visually, can you kind of, you get an idea?
Yeah.
Make it more kind of dramatic looking. Imagine that's the same curve. I'm finding this area, okay? Mm-hmm. And to do that, we use our definite integrals. So we do exactly the same thing as before. We integrate. So when you integrated this, you got x to the 4 over 4 plus x squared. And this time you put down 2 big brackets. So you don't need your plus c for this one because you're doing it's a definite integral. Yes, Jesse?
So is it always, whenever you find that, is it always between x equals 1 and x equals 2?
No, these numbers could be anything.
Okay, so it's just between the top number and bottom.
Yeah.
Okay.
Yeah. So this could be like 10 and 100, okay? And So we're down to this point, we've integrated, we've got our values. Now all we need to do is we substitute our values in for x each time, okay? So we're going to have 2 to the power of 4 over 4 plus 2 squared. I've substituted the 2 in, okay? Then I'm going to substitute the 1 in. 1 to the power of 4 over 4 plus 1 squared. And what you do is you subtract these from each other. These are 4, 8, 16. And you want to be careful with your subtracting off all of this. You want big brackets so you don't mess up any negative signs, if there are any. That's minus a quarter, minus 1. So that's 4 plus 4. Take away a quarter, take away 1. So the area underneath the curve between 1 and 2 is, so that's 8, take away 1 is 7, 7 take away a quarter is 6 and 3/4. Is that okay, Marco? Oh, sorry, Marco, I thought it was. My bad. Can't see a thing, can you? Apart from my face, probably. Which is not. Oh, yeah. There you go. Is that okay? Everyone? Yep. So I'll give you a nice easy one. Let's integrate between 0 and 2. X squared with respect to x. So you're finding the area underneath the graph of x squared between 0 and 2.
Do we need to graph it?
Nope, you don't need to graph it, but I want you to kind of visualize what you're actually doing, okay? This is the area that you're working out.
Yeah, 3 a.m. last night.
Yep. Are you up there with, you don't have Wi-Fi?
Yeah, I do.
What are you doing? What do you do?
Last night I was
What did you get when you integrated, Jaden? Yep. So you get x cubed over 3. Put this, I like to put it in big brackets so I know what I'm putting in. And I'm substituting the numbers 2 and 0 in, okay? So I put 2 in first, 2 cubed over 3. I put 0 in, so it's going to be 0 cubed over 3. And what do I do to the two things? Subtract them. This is just 0, so I end up with 8 over 3. Or 6 and 2/3? 2 and 2/3, yeah. Make sense? Okay, what about this one then? Now, of course, you can put in negative numbers as well, okay? let's do, no, sorry. Let's change that to make it a bit easier. 4x cubed minus 2x. Just take your time, be careful. Oops, sorry, Marco.
I didn't yes.
Okay, Jesse, tell me what you get when you integrate.
Oh, just it's x to the power of 4 minus x to the power of 2.
X to the power of 4 minus x to the power of 2, good. And we're doing between 3 and -1.
Yes.
Okay, now this is where you need to be careful, obviously, because we're sticking these values in and you need to be very careful of your positive and negative. So, first thing we do is we put in our 3. So I get 3 to the power of 4 minus 3 squared, correct? Then we put in our -1, and I'm going to be careful because it's -1 all to the power of 4. Subtract off -1 all squared. And we subtract these two things, okay? Is that okay with everyone? Okay, 3 to the power of 4 is what, Ari? 3 squared is what, Ari? Right, and I'm subtracting off. I'm going to still leave this in brackets because knowing my luck today, I'm going to make some mistakes here. -1 to the power of 4 is? +1. -1 squared is?
1.
And I'm subtracting that off, yep. So I'm actually subtracting off
0.
0, right. So it's just 81 take away 9, which is 72. Hands up if you got it.
Yeah.
Good job. Nice. So you can see, look, they're not that difficult. You just got to be really careful of your positive and negatives and all that jazz.
I thought the 3 squared would change the symbol. Plus, they changed it to a plus. 3.
They're where?
That would change to add.
Yeah, that's what I thought.
No, because you're putting 3 into this, so you're subtracting off 3 squared as opposed to subtracting off -3 squared.
Okay.
Yeah. Okay, let's just do a little bit of practice on this. Definite 444.
Is that the math thing? You actually- Well, I tried that once.
So nice.
Yeah, let's have a look at. So this is from the SL book, page 445, exercise 10F.
Could you have this x to the power of 4?
As well as page 454, exercise 10L. And Marco, if you have a look at these as well, okay? Yes, you should have. It should be on Teams, okay?